Hi, my name is Daisy Banda, and I will describe how certain factors affect acid strength. First of all, acid strength is measured by the ability of the acid to ionize into cations and anions. The ionization of an acid is affected by the bond strength, which is measured by bond enthalpy, and bond polarity, which can be determined by looking at the electronegativity trends in the periodic table. I will discuss how these two factors affect acid strength in the hydrohalic acids, and then I will talk about the oxoacids. So I will begin with looking at the bond enthalpy of the hydrohalic acids, which are the binary acids made up of a hydrogen atom and a halogen. Just as a reminder, according to the textbook, bond enthalpy is the change required to break a bond into 1 mole of gaseous molecules to stabilize the molecule. Of the hydrohalic acids, hydrofluoric acid has the greatest bond enthalpy, meaning that the hydrogen and fluorine bonds are stronger, so more energy is required to break the bonds. So this makes hydrofluoric acid a weak acid. Hydroiodic acid, which contains the halogen iodine, has the lowest bond enthalpy, making it a strong acid because the bonds are weaker, so less energy is required to break the bonds. So looking at the periodic table, the bond enthalpy of the hydrohalic acids decreases as you go down the group, and the strength also it increases as you go down as well. Now I'm going to move on to bond polarity of the hydrohalic acids. In the halogen group, instead of the strength increasing going down the group, it's going to decrease. To determine bond polarity, you have to look at the trends of the electronegativity. Fluorine is the most electronegative element on the table, so it is the strongest, making the hydrogen and fluorine, the hydrofluoric acid, the strongest, and hydroiodic acid the weakest. However, bond enthalpy is seen as the predominant factor in determining strength. Next, I will talk about the oxoacids. Each oxoacid has a hydrogen, an oxygen, and another atom, and it can also have attached groups. One way to determine the strength of the oxoacid is by looking at the electronegativity of the other atom. You can determine which oxoacids are stronger by looking at the electronegativity trends on the periodic table. The more electronegative the element is, the more likely this bond will be covalent, and the bond between the oxygen and the hydrogen will be polar. This will make the hydrogen more likely to be donated as a H+ ion. So the more electronegative the atom is, the stronger the acid will be. There are two groups of the oxoacids. The first group of the oxoacids have different central atoms from the same group with the same oxidation number. Using an example from the book, we have chloric acid and bromic acid. Chloric acid would be stronger because the central atom chlorine can attract an electron pair more than bromine and bromic acid due to the higher electronegativity. So if the oxidation numbers are the same, you can always look at the electronegativity of the two acids. The second group of the oxoacids, they have the same central atom but different numbers of attached groups. The oxidation numbers increase with acid strength, and looking at this example from the book, we see that HClO4 is strongest because it has a greater number of electronegative oxygen atoms attached, and this increases the oxidation number, making it stronger. So to recap, I discussed how bond enthalpy and bond polarity affect acid strength of hydrohalic acids, and how to determine the acid strength of oxoacids by looking at electronegativity and the oxidation number. Thank you for watching.